before I forget. All right, guys. So we're going to go ahead and start. Just as a quick review, um, yesterday when we were on live, we discussed the metric system, and I showed you guys a couple of things that you needed to know as it relates to. Yes, let me tell you, lo-fi is what's up for real. Yes, 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 yes. I am going to do a quick recap on what we talked about yesterday, and then we're going to transition over to our lesson for this afternoon. So yesterday, we got into the metric system, and I showed you guys some easy, practical ways in which you all could actually use this information to help you all in conversions. A lot of times, this is the introduction to chemistry in terms of what you need to know, and also things that you need to do in terms of your conversions from one unit to the other. The metric system is quite simple because you're just moving your units based on the units of tens. However, what we're going to get into today is not quite as straightforward and simple in terms of your conversions. So when we go through the metric system, we're just moving our decimal places to the left or to the right. But when you get to the metric system, you're going to actually use numbers that are like different, if that's a better way to put it. Okay. So we did this particular lesson yesterday. So if you weren't here, you can always catch this video on my YouTube channel, which is Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. Now, something else I want to show you all as we. Before I forget. Whoop, something else. Hold on one second, y'all. I think yeah, hold on one second. It is here. I have to mute myself here. There we go. All right, so what I'm going to do, and it is on a delay, for those of you all that are wondering what's going on, it is on a delay on YouTube. Now, back to where we were. So what we have here with the metric system is quite simple. You're moving your decimals to the left or to the right. Now, when we get into the metric system, or rather the English system, you have to know a couple of conversions. For instance, if you are converting, let's say, a gallon to a liter, you have to know that 1 gallon is equal to 3.785 liters. If I ask you to convert a mile to a kilometer, you have to know that 1 mile equals 1.609 kilometers. Now, you're probably saying, who remembers all of that? I know I don't. However, I will provide those for you during our live, but also, too, if your teacher is the type of person that says you must memorize them, which I don't see the point in doing that, but I digress, put them on note cards so that you're able to keep up with that information, okay? Put them on note cards so that you can keep up with that information. Now, I'm going to go ahead and switch over to what we're getting into today as it relates to that particular lesson, okay, on the metric system. So let me go ahead and grab that for you all now. Oh, a wrong screen share, okay. There we are right there. So as you guys are coming in, hello, Mihak, how are you doing today? Welcome back. Hello, Victoria. Thank you guys so much for hitting the screen and sharing the sharing the live out. I appreciate you guys. So what you have here today, I'm going to show you guys some easy ways in converting using the English system. Some easy ways. Now, I know right now it's track season. A lot of kids are participating in AAU track and all that fun stuff. But here's the thing, too, even with that, I used to be an avid runner, and I know oftentimes, hey, I'm doing well. You're welcome, Victoria. I know that back then when I was running, and I'm still kind of semi-active in running, I know that we used to do 5Ks like it was nothing. A 5K is equal to 3.1 miles. Now you're probably saying, okay, I got you on that. How do you know? Well, there are different systems that you would have to know in terms of the conversions from the metric to the English. So what I'm going to do is kind of go through something similar to that with that in terms of these problems here. So let me go ahead and zoom in a little bit on the problem itself so you all can see that. Okay. I'm going to zoom in a little so y'all can see. That's too much. Too much. Okay. There we go. And now I'm going to show you all how to solve a problem of this degree. So unlike the metric system where you had a system where you're just simply moving your decimals to the left or to the right, in this particular example, though, you're not doing that. You're actually having to set it up and do what's called dimensional analysis. Dimensional analysis means if you look at your problem, okay, like in this example here, okay, it says Nurse Johnson needs to administer a liquid medication to a patient. The prescription is for 2 teaspoons of medication. How many milliliters should Nurse Johnson administer, knowing that 1 teaspoon equals to 4.92892 milliliters? Okay, so they've given you several things within this problem. What you need to do first is start with the number that they gave you, the 2 teaspoons, okay? That's the medication that you're going to administer, but we need to convert that to a milliliter, okay? So how do you do that? Well, you're going to take your 2 teaspoons, okay? And you're going to say, all right, 1 teaspoon on the very bottom is equal to that number that they gave you, which is the 4.92892. All you need to do also is just go ahead and cancel out your teaspoons because they are canceling out. They're the same on the top and the bottom. So now all you have to do is multiply 2 times 4.92892. Now, I know nurses are not about to record all of those significant digits. So for the sake of this problem here, and what I would do as a teacher is I would say, make sure that all of your answers are going to be in, we're going to say 4 significant digits, okay, for the sake of argument. So every answer that we calculate, depending on what it is, I will tell you how many significant digits I want your answer to be in. Right now, this big number here, the conversion factor, is in 1, 2, 3, 4, 5, 6 figs, but we're not going to record that because, again, most doctors and nurses aren't doing that either. So we're going to say 2 times 4.92892, okay? And that gives us 9.857, okay? 9.857. So there's an 8 on the end of that number. And because I told you guys that I want your answer in, let's go with 3 significant digits. That way we can just round it off that way. If I want my answer in 3 significant digits, that means I'm going to highlight the 3 numbers that I need, and then the 7 tells the 5 to round up. So this answer actually becomes 9.86 milliliters, okay? And I forgot to put my mLs at the very top in terms of the units. So 9.86 milliliters is the answer. Okay. It's that simple. All you have to do again is look at the conversions that they're giving you and take the number that you start with. So in this case, we were given 2 teaspoons. Our conversion was that 1 teaspoon equals 4.92892 milliliters. All you have to do is start with that 2 teaspoons number. On the very bottom, the 1 teaspoon here that they gave you as a conversion goes on the very bottom. And on the top, the 4.92892 milliliters goes on the very top. And you just cancel out your units that are the same and give your answer accordingly. Okay? That's simple. Let's take a look at the next problem. And if at any point you need me to slow down, let me know and we will do that, okay? If you need clarifications, let me know that as well. All right, in question number 2, it says, Nurse Amina is caring for a patient who weighs 150 pounds. She needs to record the patient's weight in kilograms. How much does the patient weigh in kilograms? Knowing that 1 pound is equal to 0.453592 kilograms. What you have to remember in this problem also is that not everyone deals with pounds here in the US like we do. In other countries, they record their weight in kilograms. Now, I like the kilogram value because it makes me appear to be smaller, okay? So when you look at this number here, they told you that there was 150 pounds. That's what the patient weighs. But we know that 1 pound equals 0.453592 kilograms. So that's your conversion factor right there. So all you're going to do is take the 150 pounds and say times. Now remember, on the very bottom, 1 pound goes there. And on the very top, 0.453592 kilograms. So now for this particular question here, I want your answers to be in 2 significant digits. And you're probably saying why? Because right here, our answer or the number that they gave you for the patient's weight is 150 pounds. So all we're going to do now is say 150 pounds times 0.453592. And you get 68.038. Okay, so again, you get 68.0388. Okay, you get all those numbers. But remember, we said we want the patient's weight in 2 significant digits. So in this case, I'm going to simply say 68 kilograms. Okay, 68 kilograms. Again, we just cancel out those pounds. It is that simple. It is simply that simple, okay? Now, keep in mind that when you're doing problems of this nature, you always want to read to make sure what are they giving you and what are they looking for, okay? What are they looking for? So we're going to do another problem, because again, I'm all about doing multiple examples so that if you're doing this at home or with your teachers or you're assigned homework problems, you know what to do. Okay? So on this next problem right here, IV fluid administration. Okay, Nurse Malik is setting up an IV drip for a patient and needs to convert the volume from fluid ounces to milliliters. The order is for 12 fluid ounces of saline. How many milliliters does Nurse Malik need to prepare, given that 1 fluid ounce is equal to 29.5735 milliliters? So again, all you have to do, okay, when you actually do these problems, you just have to know, all right, they told you that the patient requires 12 fluid ounces of saline. But what they also gave you here was that 1 fluid ounce equals to 29.5735 milliliters. So again, all you have to do is say, okay, 12 fluid ounces times. Now remember, on the bottom, what you're trying to get rid of are those units of fluid ounces. So we're going to just cross those out. And on the very top, I'm going to put that 29.5735 milliliters. Now, again, I want my answer in 2 significant digits. So let's go ahead and multiply this number out right here. So we've got 12 times 29.5735. And that's equal to, so I'm going to write everything out, 354.882 milliliters. But remember, I want your answer in this case to be equal to 3 significant digits. So let's round our answer to 3 significant digits. I'm going to highlight what I know. The first three numbers are 354. The number 4 is the third significant digit, but that 8 tells that 4 to increase or to round up. So your answer becomes 355 milliliters. Okay. Now, if you've forgotten how to do your significant digits, significant figures, I recommend that you go back to some of my videos that talk about significant figures, significant digits, so that way you can get a refresher. Because I promise you, when you go through these problems, they're not going to put the answer based on what your calculator gives you. Instead, they're going to give you the answer based on the correct number of significant digits. Okay, so you got to make sure that you put your answers appropriately in the correct number of significant digits. All right, any questions so far from anyone? If not, we're going to keep on moving. Now, this one is on temperature conversions right here. And with temperature conversions, okay, let me go ahead and scoop this up. Here we go. You are given several different temperature conversions based on what you need, okay? So you have a conversion and they may say use Celsius equals 59 times Fahrenheit minus 32 degrees. So let me show you all, again, another example using that as well, okay? Again, there are several different types of conversions. You work with the one that's equal or that makes sense for you, okay? You work with the one that makes sense for you. Okay. So let me see if I can actually give you all another one that deals with temperature conversions. Oh, yes. Hey, Justice. And this, you're right on time, honey. You're right on time. Because let me tell you, whenever you all are taking classes and things appear to be hard, it's better to go and binge watch what you need to know beforehand so that it comes as second nature once you get into that program. So, yes, I'm so glad you said that. So, Nurse Justice, I'm going to put you in this problem now. Nurse Justice is monitoring a patient's temperature. The patient's temperature is recorded at 101.3 degrees Fahrenheit. She needs to convert this temperature to degrees Celsius for the medical record. Use the formula. And then I give you the formula here, but let me go ahead and actually do one thing for you guys. There are different formulas that you can actually use if you're going from degrees Celsius to, or actually degrees Fahrenheit rather, to degrees Celsius. So I'm going to work with this one right here. If you're trying to find the degrees Celsius, okay, one that you may have seen looks like this. Okay, degrees Fahrenheit minus 32 divided by 1.8. So we're going to do this two different ways so that you all are able to see how simple this can be. Okay, meaning there are different ways in which your temperatures can be provided. So what I know in this particular problem is that they gave us 101.3 degrees Fahrenheit. So I'm going to write the first formula here. The one here, I'm going to use the degrees Fahrenheit, which is 101.3 degrees Fahrenheit minus 32, and then divide that by 1.8. Okay? Yes, 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 yes. It's okay if you forget. It's okay. So you're going to say 101.3 minus 32. Do what's on the top first. Then divide that by 1.8. And we get 38.5 degrees Celsius. 38.5 degrees Celsius. Now, in this case, since the patient's temperature was in 4 significant digits, what I would recommend that you do, for the sake of the problem, you can put it in 3 significant digits if there was no questions asked or if they didn't clarify. But if I say put this answer in 4 significant digits, you would say 38.50 degrees Celsius. Okay? So it's the same thing in terms of what you're having to do to calculate your answer. Okay? So now I'm going to actually take this one off right here. Matter of fact, hold on 1 second. I prefer that you guys use this formula here, the one that I wrote in red. Use that formula, okay? Use the formula below, okay? That's the one that you should use, okay? And again, different chemistry books will give you all different formulas. You want to use the one that's easiest for you, and this is the one that's most identifiable. All right, let's move on to the next problem. Ooh, this is a lot of conversions here, and let me tell you why. Okay, let me tell you why. It says infant weight conversions. So you have several things going on within this problem, several different conversions. And it says Nurse Tiana is conducting a health check on a newborn. The baby weighs 7 pounds, 8 ounces. She needs to record the weight in kilograms. Note that 1 pound equals 0.453592 kilograms and 1 ounce equals 0.0283495 kilograms. Now, I know that's a lot of numbers. Some of your books will actually round the numbers to like maybe the first 4 significant digits or the first 3 significant digits. But either way it goes, whatever you're given, that's what you want to work with, okay? So now in this particular problem here, you're having to convert your pounds and ounces to kilograms. Now, there are some that will say, or some references that will also give you 1 pound, okay? Or excuse me, let me rephrase that. That 1 kilogram equals 2.205 pounds, okay? But see, in this case, they gave you pounds and ounces within the same problem. So you're going to have to do 2 conversions in this particular example. So for the first part of what we're going to do, we're going to actually take the 7 pounds. So step 1, okay, convert 7 pounds to kilograms. So for that one, we're going to say 7 pounds times, and again, on the very bottom, 1 pound, and on the very top, we're going to use this conversion here, okay? The 0.453592. Again, we're going to cancel out our pounds here, okay? And again, that's 7 pounds for those of you out that are looking at that number, not 71, that's 7 pounds. Okay. And we're left with kilograms. So what are we going to do? We're going to say 7 times 0.453592. And we get 3.175. So for the sake of this problem, let's go ahead and say 7.18. We're going to use 3 significant digits. Okay? 3.175 for the 3 significant digits becomes 3.18 kilograms. Now, we can't forget about the 8 ounces. So for step 2, we're going to do that conversion as well. Okay? So for step 2, you've got to convert 8 ounces to kilograms. Okay? So in this particular case, and let me scoop the screen up a little bit. We know that 8 ounces times, use our conversion factor here. On the very bottom, we're going to put 1 ounce because that's what we know from our conversion in this particular case right here that I'm underlining. And on the very top, 0.0283495 kilograms. So again, we're going to have to do what? Cancel out our like terms. The ounces goes away. But what we're left with are the kilograms. Okay. So again, we're going to go ahead and plug this into our calculator. 8 times 0.02834 or 95. Okay. And that equals 0.2267. But again, we only need 3 of those numbers. So we're going to round this off to 0.227 kilograms. So what are you going to do? You've got to add these two numbers here that you just solved for. So in this first example, we converted the pounds to kilograms. And in the latter part of that weight, the 8 ounces, we converted to kilograms as well. What you're going to have to do is add those two together, okay? So we're going to add those two together, and you're going to say 3.18 plus 0.227 gives you, and this is where those significant digits come into place, 3.407. But is that the correct answer using the correct number of significant digits? No. You've got to make sure that your answer based on the sig figs rule tells you that when you're adding and subtracting, you go with the least amount of digits after the decimal. In this first value here, you have 2 numbers after the decimal, that 0.18. And in this bottom number here, you have 3 numbers after the decimal. But in this case, our answer will be finalized at simply being 3.41 kilograms. So this baby actually weighs 3.41 kilograms. So don't be intimidated about problems of this nature. Whenever you're given examples where you're having to do multiple steps, it is okay. Take your time, do one problem at a time, and before you know it, you will have solved your problem. Okay? It is that simple. It is that simple. Okay. Hey, Yana, baby, it's been a minute. How you doing today? All right. So now, oh, did you, Justice? Nurse, I'm gonna start calling you Nurse Justice. Did you? You had a similar question like this on, okay, very good. Yes, Yana, baby. Yes, 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 yes. I remember you were rocking with me since the beginning of the semester. I remember you. And you had a unique name. Yana, baby. Yes, I remember. I remember. Yes, thank you so, so much for that compliment. Yes. All right. I love these success stories, y'all. I really do. That's why I go hard every day giving out free tutoring because I'm not trying to be in anybody's pockets, but I know students don't oftentimes have the money to pay for personal tutoring, one-on-one tutoring. And sometimes students are, I don't want to say embarrassed to go to the tutoring center, but they are intimidated to go to the tutoring center. So they don't like to get the help that they need at that time. So I do what I do. Okay. I fill in those gaps to help students like Yana, baby. All right. Blood pressure cuff calibrations. This might be something similar. Thank you, Victoria. Thank you. This might be one that you guys will see also. Now, we're actually ahead in terms of doing a problem with pressure, but how many of y'all have taken your blood pressure and you know your blood pressure? I pray that you guys do not have high blood pressure. Now, I know chemistry will make you want to say that you got high blood pressure, but make sure y'all know your numbers, okay? Know your numbers. I don't have high blood pressure, thank God, but I also know that we've got to still move and stay fit. If you look at a lot of older people that are still exercising, they're trying to maintain or exceed their health regimen. Yes, that's right. You got to know your vital signs. You need to know your sugar. So you know if you're pre-diabetic. You need to know your blood pressure. You need to know your cholesterol levels. Okay. That's my health word for the day. So in this next problem that deals with blood pressure, Nurse Coffee, or Kofi rather, Nurse Kofi needs to calibrate a blood pressure cuff that is initially set to measure in inches of mercury. The reading shows 5 inches of mercury, and Nurse Coffee needs to convert this to millimeters of mercury for accurate documentation. 1 inch of mercury is equal to 25.4 millimeters of mercury. Oh no, Justice, we got to reverse those numbers, honey. We're going to have to reverse that. And you know what? I actually, and I'll have to get this book, but it's one of the books that I'm going to be talking about that's in my shop, where it is the one that's been going viral on social media, on TikTok, because there are different things that you can actually take in order to reduce that. Yes, we can reduce that. We can reduce that with some natural stuff. And I know it's not always as easy as it sounds, but there are some practical things that you can do. Okay. So in this particular example here, you've got a reading that says 5 inches of mercury that we need to convert to millimeter. I just got tongue twisted. 5 inches of mercury that we need to convert to millimeters of mercury. So this is quite simple. All you're going to do is put on the very bottom 1 inch of mercury, and on the very top, the 25.4 millimeters of mercury. And of course, you're going to cancel out those like terms, those inches of mercury, all right, and multiply. Now, in this particular example here, yes, you're going to be given 3 significant digits, excuse me, because you're going to multiply 5 times 25.4. And so you're going to write your answer with those 3 significant digits, 127 millimeters of mercury. Okay. Y'all doing all right out there? Y'all understand what's going on? Remember, if at any point you don't know what I'm doing, tell me to slow my roll and we will do that. Okay. We've got a few more problems. And the next example, yes, thinking too much. Yes, I know a lot of students do that. And it's like, you know what? You don't have to overthink the problem. Just work with what you got. Okay, work with what you got to make it easier. Okay, to make it easier to understand. So let me do this next one with you. Okay, now I know this is going to seem like it's a lot, but again, you don't have to overthink this particular problem. Okay, so this is dealing with urine output measurements. So again, Nurse Justice, I'm putting you in all these problems now. We got Nurse Justice. I know it says Nurse Naomi on the problem on the screen, but I have a student, for those of y'all that are on YouTube, I have a student that's with me on TikTok, okay? So Nurse Justice needs to measure a patient's urine output, which is recorded in cups. The patient has urinated 3 cups over the past 8 hours. How many milliliters is this, knowing that 1 cup is equal to 240 milliliters? All right, so let's look at the conversions that they gave you. 1 cup is equal to 240 milliliters. The patient urinated 3 cups. So all you need to do, again, this is simple, guys. 3 cups times And remember, on the very bottom, 1 cup for that metric, that unit that you're using here. Get rid of the cups. And on the very top, 240 milliliters. Okay, so what you're going to do again, you're going to say 3 times 240. And you get 720 milliliters, okay? 720 milliliters. That is correct, Justice. Nurse Justice, you're multiplying. That's correct. 3 times 240. Yes. All right. Now, we've got another problem. We've got, I think, 2 more problems, or 3 more problems to go. Okay. So right here, let me put this on a different screen. There we go. So right here, see that blood pressure one is coming up. Yep, that one is coming up. Nurse Kenyatta is helping a patient manage their diet. The patient consumes 64 ounces of water daily. Get y'all's water intake, guys. Technically, whatever you weigh in pounds, you should put that half of your weight in ounces. So for the sake of numbers, if you weigh 200 pounds, then half of that is 100. So you need to be drinking at least 100 ounces of water. FYI. If you weigh $150, I haven't seen that number in so long. $150, then half of it is 75 ounces. Okay. That's just a little FYI in terms of your water intake. Get your water, and you can also get it from fruits. Watermelon is in season now, so you can, get your watermelon intake, and that will keep you hydrated too. So this patient consumes 64 ounces of water daily. How many liters of water does the patient consume, given that 1 ounce is equal to 0.0295735 liters? All right. So what are we going to do? We're going to set this up again and say 64 ounces times, again, on the very bottom, 1 ounce. And on the very top, you're going to put 0.0295735 liters. That is correct, Delaflor. That is correct. And let me tell you guys, why do I always write these out? Because your teachers may say, show your steps. And I know that Justice was also saying, yeah, see, I just answered your question, Nacho. I'm right there with you. Because so many teachers will tell you to show your steps. And this is called dimensional analysis, where you're showing your steps and you're using the appropriate conversion factor. And it also helps you so that just in case you're having to convert multiple times, multiple steps, you'll know exactly what to do. No problem. You're welcome. You are welcome. So I'm going to give you an example of that so that way you can see what I'm talking about. Okay. So you have 64. Thank you, thank you, thank you. Appreciate that. Nacho 5599. You've got 64 times 0.02. Whoops, I went too far with the zeros. 0.0295735. And you get 1.89. Okay. 1.89 liters. But suppose we said, let's just round this off to 2 significant digits. Well, you could say 1.9 liters. Okay, 1.9 liters. Now, Nacho asked a very good question about why do we use the line on the very bottom? So I'm going to give you another example where you may have to do multiple steps. Okay, suppose you had an example where you have to convert that to, let me think for a second. Let's say that you had to convert this number here to gallons, okay? So you got ounces to liters to gallons. Well, if you know how many gallons is in a liter, okay, then that also helps you. Now, the reason why I know this number that I'm getting ready to tell you is because I'm trying to drink a gallon of water a day. So I know that a gallon is equal to 3.79 liters. Now, I don't want to mess up my thing, but here it is right here. Okay, you see that? Okay, so now what you're going to do, if you were starting this answer, this question from top to bottom, where I told you to convert 64 ounces to a gallon, okay, then what you would have to do in a multi-step problem like that, again, let me put that conversion over here too. 1 gallon equals 3.79 liters, okay? 3.79 liters. So what you would have to do is take the 64 ounces that the person says that they're drinking times, and on the very bottom, we're going to say 1 ounce, and that's, again, equal to that number, 0.0295735 liters. Again, some books are not going to give you this long number, okay? Just FYI. And then you would take your ounces, cancel those out. And then on the very top, you're going to also say, well, on the bottom, rather, 1 liter, so you can get rid of your liters there. And on the very top over here, you're going to say 1 gallon. And then that will give you, whoops, not that number, 3.79 liters. Because 3.79, and let me zoom out a little so y'all can see the screen. 3.79 liters is equal to a gallon, okay? So that's why you would have to constantly cancel out your like terms of what you got. So if we plug this in to our calculator, okay, and then divide that. So again, remember, we multiplied 64 times 0.0295735. And then in this last step, we would have to take that number and divide it by 3.79. Hold on. I gotta start it over, y'all. Thank you, Sod Cal. Thank you so much for saying that. Still double tap, guys. Thank you, thank you, thank you. I appreciate that. Yes, we need all of the support we can get over here. So yes, there's that number right there, the 1.89, that long number divided by 3.79. And you get 0.499 gallons. Okay? Roughly half of a gallon. Roughly half of a gallon. Okay? Roughly. All right, so that's just one example there in terms of multiple steps and why I'm using the conversion factor saying over 1, because sometimes you may have to flip it and say, you may have to convert the liters to an ounce. And this time your ounces will be on top and your liters will be on the very bottom. Okay? All right. Let's do let's see here. I'm going to save number 8 for another time, because number 8, this is dealing with density. And I know it deals with the patient's sugar blood level, but in order for you all to understand what I'm going to do with this particular problem, I've got to show you how to do a density problem. So I'm actually going to table that problem for Monday. Wait a minute. Monday is Memorial Day. Y'all probably not coming on here on Monday. I don't know. I might come on Monday because I know it's Memorial Day and y'all may be cooking out or barbecuing. You may not even want to do any chemistry, but I may have a lesson on that for y'all. Now, for the medication problem, I will do this and we'll close it out on this one right here. So it says Nurse Jamal, okay, is preparing a medication that is available in a concentration of 50 milligrams per teaspoon. 50 milligrams per teaspoon. The doctor's order requires 200 milligrams of this medication. My question is, how many teaspoons should Nurse Jamal administer? Again, all you're doing, guys, if you notice here, they told you 50 milligrams per teaspoon. The doctor wants, though, 200 milligrams. So, well, it requires 200 milligrams. How many teaspoons, though, is that? Okay. So, in order to do this problem, you should first start off with the 200 milligrams. Okay, let's see. Ezra Light says 4 teaspoons. Let's see if you're right. So you've got 200 milligrams, okay, times. So again, because we want to know teaspoons, you're going to put the teaspoon on top. So this is where you're going to have to flip this conversion right here. You see this? That 50 milligrams per teaspoon, you're going to have to flip it. And what do I mean by flipping it? That means because you're looking for teaspoons, you're going to say 1 teaspoon over 50 milligrams. And there you have it. And you know what? Israelite, you are correct. So you're going to cross out your milligrams, okay? And just simply divide 200 divided by 50, and you get 4. You are right. 4 teaspoons is how much the nurse is going to administer. All right, guys. You all have been so great today on this live. And listen, I do have a quiz that you guys can take, and it's on my page right now. For those of you all that are on YouTube, I'm going to actually put this quiz up as a short, so you'll see it over there. But I'm going to close you guys out on YouTube, but I'm going to show the quiz to you all now on TikTok. So, okay. So hold tight. Let me go ahead and end this on